Hey everybody, so I am Matt Topol. I'm a software engineer at Voltron Data. And to get this going, so why should you care at all what I have to say? So I am on the Apache Arrow PMC, the Project Management Committee. I've been the committer, I've been working with Arrow for quite a while, and I get to say I wrote the book on Arrow because there's just the one book, that's that one right there. So feel free to, if you're interested in Arrow or like Arrow, go grab a copy. It's kind of fun. I'm on Twitter, LinkedIn, and a lot of fun stuff. But let's just get down to the topic here. So when I gave the idea for this talk, I thought it would be interesting because we want to kind of help push Arrow more into the machine learning contexts. But one thing I need to get across from the start is that I am not an ML expert at all. My expertise is distributed systems, data transport, and complex interoperability. So I had to do a bit of research and talk with some people to figure out exactly where to go with all this. And I came up with this. And let's see, I was hoping for more laughs, but now I'm worried. Based on what I could find and talking to a lot of people and looking at tutorials and articles and anything I can find, basically everything kind of boils down to, at a very high level, you're going to have tons and tons of data, and you need to get that to a black box that's going to do computations, your actual ML analysis, your building the models, you have your training to create the models and have your iterations going back and forth until you finally do that. And then you're going to have infrastructure set up to actually serve that model and then have feedback and do all the fun things. So at a very, very high level, most ML systems are going to look like this to some degree. Very oversimplified, I'm aware, but it gets the point across. And across all of those things, you have your data. You have to get your data over to whatever's doing the actual computations. You have to go through training. You have to represent the models. You have to pass data around all of these complex systems, interoperate with all of these libraries. You have infrastructure for serving the models. You have where your data is coming from. You have feature stores, the whole 9 yards. Now, if every time you have to take data and go from one place to another, you have to change the format or translate it or serialize, deserialize, it gets expensive. And not only that, but a lot of the tools and utilities don't speak the same formats. And then you try to switch from one library to another, and now you have to do a whole bunch of work to shift it around. Or if you want to just put these things together, you end up with these difficulties and these problems. So putting all of these things together is constantly a pain, and the name of the game is interoperability. You want to make it easy and convenient to communicate and get data between these systems, moving across these utilities, these tools, these libraries, and make it easier, but also not sacrifice performance to do that. So we're going to take a short detour into what Apache Arrow actually is, because, well, that makes more sense if I tell you what it is, and then go into how it can be useful for these things. So Apache Arrow itself is a format. It is a columnar in-memory format for high-performance analytics, computations, data manipulation, and has implementations in ridiculous number of languages. Essentially, in the vast majority of cases, if you want to use Arrow, you probably can in your environment, and it will probably be pretty easy. The basic idea here is you have all these systems that want to communicate. And way, way back when Arrow first started, the big thing at the time was Hadoop. And when you're trying to communicate all these systems and you have to send data around, every time you're passing data, you have to copy it, convert it, serialize, deserialize, and like 70, 80% of your compute time was just the systems serializing and deserializing the data every time you went through it. Arrow's in-memory representation is identical in memory as it is on the wire. You just take the raw bytes and pass it off, which means that you're not paying that serialization or deserialization overhead cost. You can just throw the buffer on the wire, use it as is, no copies, reducing all of the copying, and making everything in general much more efficient and faster. If you're not familiar with column-oriented, here's a nice little graphical depiction of what I'm talking about. It's kind of the classic, struct of arrays versus array of structs type of discussion. When you have the data in certain chunks in certain ways, you want to take advantage of vectorization, SIMD, analytics, computations. And that's what you get with this column-oriented. Why would you use column-oriented data? Well, there's a reason why the vast majority of analytical compute libraries nowadays are using column-oriented systems, because you get less I/O and lower memory usage when you're trying to interact with one column or compute some combination or analytics with two columns, so on and so forth. Parquet is a column-oriented file format because if you only need a couple of columns out of your entire data set, you only have to pay the I/O for those columns, not every row you do. And that's kind of the big difference there. If you're trying to do compute analytical, you're trying to do, let's say, the mean of a column, or you're trying to do just simply add two columns or anything like that, you want to take advantage of things like SIMD, single instruction, multiple data. One CPU instruction, compute something across a whole bunch of data points at one shot. To do that, the data has to be in a contiguous single chunk of memory, because that's how the instructions in the CPU works. With a column-oriented data set, your data is already in that contiguous chunk of memory, because that's just how it's represented in memory through the whole system. And then, therefore, you can just already utilize those without an extra cost of having to reorganize or reorder your data. It just works. And a lot of the libraries that exist that use Apache Arrow leverage those capabilities. Now, now the rest of this talk is more on just specifically using Arrow in the ML context. If you want to know more about Arrow in general, I'm giving another talk tomorrow, which is much more in-depth on Arrow, the project, and other libraries and tools involved there. So let's hop back to our machine learning use cases. Now, from what I could tell from a lot of people I talked to and a lot of articles and tutorials and things, there's two big use cases. Again, oversimplifying, but there's two general use cases. Either you're a researcher, or you're productionizing a service to use a model based on techniques from those researchers. And in that situation, there's different priorities. Your researcher really wants fast iteration. They want flexibility to make it easy to integrate the different tools they want. They love their notebooks and just ease of development, interactions, maneuverability, and flexibility. When you're trying to productionize a system, at that point, you don't want necessarily flexibility. You want something you can rely on. It needs to scale. You need reproducibility. When you give it the same input, you want the same output. You want reliable infrastructure. But in both cases, regardless whether you are a researcher or you're trying to build a production system, you are going to try to pull data from many different sources, potentially store that data back for feedback or for coming back from, to help retrain your models as you go. And you have many different tools, libraries, utilities, systems that you need to interoperate between to make the whole thing work. And I have my controversial opinion. I hope no one tries to crucify me for this. But ultimately, any machine learning model, any pipeline, any machine learning workflow, whatever you're building, at a high, simplified level, it's just a special case of a data pipeline, which means we're back in my wheelhouse. My expertise is complex distributed data systems, data interoperability, and data transport, which means that since all these machine learning models and all these machine learning workflows are just a special case of a traditional data pipeline where the transformations you're applying are specific to machine learning, but ultimately you're taking data, passing it through systems, trying to push it to a user, logging, monitoring, all the usual things. Swap out the machine learning piece with any other analytical, computational black box, and your overall system isn't really much different. And so you end up with something like this. You've got your data sources. You want exploration and cleaning to be very easy for your researchers and your developers. Eventually, that data gets pushed after it's been cleaned, and you know what you want. You throw it into feature stores and catalogs in certain ways and organized in certain situations. Then you got feature engineering, where you're furthering exploration, cleaning, and manipulating that data into the right formats you want. And then once you have those models, and once you have everything set together, you're going to want to serve it, you can train it, and then you take the results of the feedback and new data and new input and retrain and the whole 9 yards. Now, in this situation, I've highlighted those communication situations. I've bolded the arrows here because the first thing we're going to talk about is that communication. You have all these systems, you have all these tools, you have your insert whichever feature store you want to use, which is a specialized database with other services involved and all that stuff. You still have to get data from here to there to there to there. You have to move the data around. And so one example is a talk that was given at PyData Amsterdam. And by using DuckDB and Arrow Flight for the communication, Arrow Flight is a framework for building an RPC communication protocol designed around streams of Arrow formatted data. And by using DuckDB, which has zero-copy interactions with Arrow via CAPI, and Arrow Flight, they were able to get 30x speedups compared to a traditional Spark and Hive data structure and analytical infrastructure. And that applies with any communication because Arrow is so efficient to use in memory, and the fact that passing it from system to system across the wire doesn't have that serialization overhead, and is significantly smaller as a binary format than, say, JSON. The more data you're throwing through the pipe, the more performance benefit you're going to see. So next, let's look at so now we've talked about Arrow with communication. You're going to get benefits with Arrow in communication, but if you then have to convert the Arrow into something for that system, you're losing some of that benefit. But you can still use Arrow in those systems. So let's look at those analytics and manipulation pieces. Arrow has a setup where you have an IPC protocol. Arrow Flight's communication IPC is wrapped around that, and one of the big benefits of that IPC protocol is that you can easily mmap that data file. And so you can have very larger than memory files that you can process and iterate and communicate and operate on without needing tons of memory, which makes it super efficient, much less memory allocating, and just lower memory requirements. The other thing is that Arrow has that C data interface. When you're communicating between different runtimes and environments within the same process, the data that is in Arrow format can be easily passed around by passing pointers with some simple C structs, which means that you're not copying the data. It becomes super efficient, and you get the zero-copy communication. If you're using polars or pandas, you're using Arrow under the hood in most cases anyways already. The entire internal representation of the polars library is Arrow. DuckDB exposes the Arrow CDA API, which means that if you want to retrieve data from DuckDB and process, you avoid a copy because it just hands you the pointers to the raw data and a little bit of metadata. And that's because DuckDB's internal memory representation is actually very similar and in many cases identical to the Arrow format already. So them outputting Arrow format is already very efficient to begin with. Then you have your standard things like TensorFlow, XGBoost, DLPack, all those things, all those ML libraries and utilities. And we're continuing to increase and develop the interactions and interfacing between those libraries with Arrow to help speed up and improve that communication. I mentioned the MMaps. I mentioned using Arrow's IPC. If you're familiar with Hugging Face, they provide a lot of data sets that people use for training, for serving, for models. Hugging Face's data sets and their entire caching system is Arrow. They write out Arrow IPC files so that they can mmap that into memory and only use the memory they need for what you want to process. In this example right here, they pulled in the entire Wikipedia set from Hugging Face to train on. That data set is several gigs. I think it's actually 50 to 100 gigabytes, that set. And right here, loading the data set with split train, for Hugging Face, it used 50 megabytes of RAM because it's using mmap. It's only going to allocate memory at the point that you try to access what you want to use. And because Arrow's IPC format is identical to the way it's laid out in memory, there's no copy conversion deserialization cost here. You mmap the entire file, and you just, whatever bytes you need are the bytes you need. Those are the ones you're going to read as is and operate on them as is right there, easy peasy, simple, because its format is identical to the way it's going to be in memory. Okay, so we've talked about where it's beneficial for feature stores. We've talked about where it's beneficial for exploration, talked about communication. Let's get into the nitty-gritty. Let's talk about actually doing that black box, that magic math of model training and serving. If you're familiar with libcuDF or NVIDIA Rapids, that's using Arrow formatted data on the GPU. That's what they're doing. That's how it's implemented. That's what it looks like. That's how it works. So you have, CUGraph, libcuDF, CUML, all their utilities and deep learning and their visualizations. They're using the Arrow data format for its benefits. They just put it on the GPU. And that also means that it becomes very efficient and very easy to pass data on and off the GPU if it's already Arrow formatted. So it makes it very easy to integrate with these libraries because the library has a to Arrow from Arrow functions that they expose to make it very easy, and the only cost there is just the copy cost of going from your host to your device. Now, the big benefits there is the longer you can keep the data on the GPU, the more efficient your whole system is. If you're having to pay the cost of going back and forth from the CPU and the GPU constantly, you're going to kill your system. So you get benefits from keeping it there. So where else does Arrow fit with model training? Well, there's something called ADBC. If you're familiar with ODBC or JDBC, ADBC is a similar concept, just Arrow native. If you want to learn more about it, come to my talk tomorrow. PyArrow, it's the Python Arrow library. It's built on top of the C++ libarrow. It's just a thin Python shim on top of C++ code. Now, it's using Arrow as its internal memory representation, obviously, and that means you have integrations with pandas, polars, NumPy, because in the case of polars is just Arrow with a different API on top. Their representation, the way they use data internally, is Arrow. Pandas 2 shifted completely to an Arrow representation. One other great example is using Pandas UDFs. If you have a Spark system and you want to pass data around your Spark system and you want to use a UDF using pandas, it supports using Arrow as the way it represents the data, so that when you're getting your data across from the JVM to the Python and back and forth, the format stays in Arrow, which means that it is extremely efficient, zero copy, just pass pointers to the bytes to access the data, which then makes the entire thing super fast. In many circumstances, Arrow can also zero copy directly convert to NumPy, which then can be imported and input into PyTorch, TensorFlow, XGBoost. All of those can zero copy with NumPy. And in large numbers of circumstances, you can easily zero copy Arrow data into NumPy. And then obviously I already mentioned libcuDF and the Rapids for doing Arrow on the GPU. So you have all these integrations and all these utilities that the interoperability, the intersection of these connections and these tools and these libraries can be Arrow. If the data format stays in Arrow, everything becomes simple, easy to do. So upcoming development, stuff we're actually working on. Remember, I'm on the Arrow PMC, and my actual day job is I just work on the Arrow libraries. That's what I get paid to do. I'm very happy for it. I'm very lucky for that, and I like it. We're working on producing DLPack buffers straight from libarrow C++ and PyArrow. Just direct, easy conversions. Now, if you're not familiar with DLPack, it is a header. It's a single header that defines a way of defining device-based buffers so that you can pass it across runtimes, like the Arrow C API, so that you can take data in, say, Python that's on a GPU and hand it off to an entirely different library or runtime without having to do the copy off the device to the host and then back to the device. Recently, we added to the Arrow C data interface a device data interface. So you can actually use Arrow's C interface that I mentioned that DuckDB has that communication with Arrow. Well, there's many other utilities that have that same C data interface communication, and we now allow systems to leverage using that C device data interface so that you can pass Arrow formatted data that's on a non-CPU device, zero copy past the buffers between runtimes. You know, you can allocate data on your device from the Numba CUDA setup, pass it through a C interface to a Rapids libcuDF C++ library, operate on it there, pass it back to Python and Numba and operate on it there, and at no point through this process do you have to copy the data off the device and back to the device to pass it around. The data can stay on the device the whole way through using this interface by passing device pointers. Arrow recently added to its format spec canonical extension types to represent tensors, both fixed shape and variable length, so that systems that rely on actual tensor setups can use Arrow to represent the metadata and the raw tensor data in the Arrow format and pass it through any libraries or systems that support Arrow without having to convert and copy and serialize, deserialize to get it through and pass it to these different systems. You can just store it and use it as Arrow, pass it through your whole pipeline without having to serialize and deserialize as you go. And then finally, we're looking at optimizing the various conversions from 2D, because, for example, Arrow and a lot of tabular data, well, Arrow's primarily currently used for a lot of tabular data, and a lot of ML systems use more n-dimensional tensors. And so sometimes there is some conversions, but we're working on optimizing those to minimize the number of copies, keeping data in the same spot. In some cases, Arrow uses multiple different buffers to represent different columns, whereas something for a tensor, you want that all to be a single contiguous buffer, those types of things. So that upcoming developments are working on optimizing those conversions for better, more efficient, more performant interchange and interoperability between these libraries and tools. So think of the idea at a high level, what you can do. You have your data sources, Snowflake, raw S3, HDFS, Postgres, Dremio, whatever. you can use a protocol like Arrow Flight SQL, ADBC, to get your data from your data sources into your libraries. You can leverage PyArrow, LibArrow, C++, the Go implementation, the Rust implementation, whatever language you want. I have not yet, there's very, very few languages currently that don't have an Arrow implementation. And then you can then take the data using these libraries and pass them to your desired ML tools perfectly efficiently, high performance, zero copy, optimized conversions if they have to convert, to make super efficient communication from your data sources to the ML libraries you're going to use, and then taking it out of the ML library you're using and putting it back into whatever data source you want for your feedback, for your updated models, for your retraining, for your model registry, setups, whole 9 yards. Arrow is that universal communication format that can be leveraged both in memory and out of. And so here's the call to action. Arrow is completely open source. All the various Arrow projects are open source. It's an Apache project. So contribute, help, support. If there isn't an integration for the tool you use, tell us. File an issue on the GitHub repo. If you run into an inefficiency, if you run into something that's not as performant, tell us. Communicate. There's mailing lists. There's a dev mailing list. There's a user mailing list. We're all very active. The project itself is super active. There's various integrations and setups. Right now, there is a Snowflake ADBC driver that was recent. DBT is looking at adding Arrow Flight and Flight SQL communication protocols for better integrations there. Trino is looking at using Arrow Flight. XGBoost and DLPack are leveraging that zero copy communications, so on and so forth. If your particular preferred ML tool doesn't have an integration, if your data source doesn't support Arrow, then convince them to. There's all the reason for them to do it. It makes it really easy for them if they support Arrow because there's all these libraries that already work with it. Or help build it yourself, contribute. Or just tell us, and maybe someone in the Arrow community already has connections. Just the whole point here is that Arrow is a standard and it's a format, and it works the best the more it's widely used and supported. And whenever there's and we won't know what the inefficiencies or cases that don't work yet if people don't try it and tell us, so that we can fix that and keep expanding it, because Arrow's being used and creating humongous performance benefits all over, and is extremely expanding across the industry. And like I said, if you want to learn more about that, come to my talk tomorrow. Keep pushing that, I just don't want an empty audience, really. So if you want more information on Arrow in general, go to the GitHub site. Go to the docs, go to the website. You can get my book, shameless plug. Fun part is whenever I do conferences, they always send me copies. So I typically will have one copy of my book in my bag every day of the conference. And if you come find me, I can give you it to you if you get there first. And you can get a nice signed copy of my book. And then you can learn about Arrow. And it has lots of tutorials. It describes the entire Arrow format. And the examples in the book are in Python, C++, and Go. One thing that people have commented on is that most technical books will pick one language and stick with it. And I wanted to showcase that interoperability aspect of Arrow. And that's why I made the examples in Python, C++, and Go throughout the book. Just practical examples, using it for Spark integrations, interactions, and communications. And so that is my talk. Thank you very much. I am a little early, so questions?
Yes, you said that Arrow is mostly for tabular data, but is it also used for, because a lot of machine learning these days are unstructured data, so I guess the Wikipedia data is a lot of text, right?
I mean, Arrow has a lot of different type supports, and you can support nested and structs and lists and maps and all these things. So if you can represent, like Arrow has union types and other things like that. So but that is one shortcoming, is that it's not the easiest to represent unstructured data with Arrow, because it is very much column oriented, which means everything in the column is expected to be one type. But that's when you get your union types and things like that, which can let you, work with that in optimized ways, but still not the most efficient in those smaller scenarios. But when you're dealing with like pure text, Arrow's great for that, and having different columns. And if you're doing analytics and you have non-text data, you have integers, you have floats, and all those, Arrow is fantastic for that when you want to perform operations, analytics, pass it around. One great example of Arrow with unstructured data, OpenTelemetry recently is shifting their format for how they communicate the traces across the wire to use Arrow for performance benefits, and saw enormous performance benefits in the prototypes that they were building by leveraging that zero copy aspect of Arrow, the IPC format, the communication, and then importing that and using it as for analytics and communications and stuff internally, and avoiding that expensive conversion to and from JSON. Because if you think about it, you have a JSON document, and if your JSON document has, to represent a single integer in JSON, if you have 12, 1, 2, 3, 4, 5 as your integer, that's 5 bytes. Whereas in Arrow, you could have a 2-byte integer, or 3 or 4, and then multiply by the number of rows you have. That becomes enormously different in terms of the size of what you're trying to pass around. And for something like OpenTelemetry, where bandwidth is the bottleneck, you want to make that payload smaller. Yep. No one else raised their hand.
If I have a project running today that's not currently using any Arrow anywhere, how would you recommend getting started to shift to using this format?
I mean, the exact ways are going to depend on what the project is. If you're getting data from a data source in the project, maybe that data source supports Arrow as an output format. That's a great way to start. Maybe if you're using pandas or polars and you're trying to pass that data between two systems, does the thing you're passing it to support Arrow? Well, then it's possible you're already using Arrow and not even realize it. Things like that. And I'm going to have a lot more examples of getting started or utilizing it like that in tomorrow's talk, which is going to go over things like Arrow Flight SQL, the RPC, the wire protocols, ADBC, and stuff like that. I'm going to have a lot more discussion of that in tomorrow's talk. And that's really the focus for that, is the whole ecosystem of how can you use it in a project and what can you get out of that, as opposed to just the more ML-focused nature here. Anyone have any questions or comments? Compliments? All right. I mean, if no one else has any questions, then thank you very much. Hope to see you guys around. Just come stop me, chat. It'd be great. Thank you.